Hello! Welcome back to New Scientist Weekly, your curated selection of the week's science stories. I'm Timothy Revel in New York.
And I'm Chelsea White in Portland, Oregon. Welcome to the show.
We're going to be taking a close look at a new nuclear fusion milestone that has now been reached, plus an unusual project that is trying to map what we don't know about the proteins our genes make.
I'm picturing one of those oldie-timey maps that says, "Here there be dragons," written in the ocean part.
I really hope it's that.
Yeah, me too. We'll also talk about how popular the moon is getting, with Russia and India both setting their sights on missions to the South Pole. And a few other bits we'll touch on. Heads up, there will be poop, very old fossilized poop.
Something for everyone. First, though, we're looking at ultra-processed foods, which are often presented as the absolute worst foods from a nutrition point of view. They tend to be things like frozen microwavable meals, some packaged bread, cookies, the sort of thing that has a lot of unfamiliar ingredients on the back and lasts an awfully long time before it goes bad. Now, these are the villains of the food world normally, but it turns out they may actually form a much more important part of healthy diets than we realize. Health reporter Grace Wade is with us reporting back from an American Society of Nutrition conference in Boston last month where this came up. So Grace, I thought we were all in agreement that ultra-processed foods should be avoided. So what's the new insight?
So it's pretty common dietary advice to eat whole foods and avoid processed ones, but some researchers and a growing body of evidence suggest that it may not be so simple. For one, there's a lot we don't know about whether they're even bad for us. For another, there's been some work that shows we rely on them for critical nutrients.
So when you say there's a lot we don't know about whether they're bad for us, I'm sure that's true, but I assume there's also their reputation didn't come out of absolutely nowhere. So before we get into the why they might not be so bad part of this, is there some evidence to back up that unhealthy association we have with them?
Yes, absolutely. I want to make perfectly clear that there is without a doubt an association between consuming high amounts of ultra-processed foods and an increased risk of developing various conditions like obesity, type 2 diabetes, and heart disease. But as you know, association doesn't always equal causation. And right now, there isn't an explanation as to how ultra-processed foods could be contributing to these diseases. Now, there are some theories. One of the more popular ideas is that because ultra-processed foods tend to contain high amounts of salt, fat, and sugar, people find them tastier, meaning they eat more. But so far, the only clinical trial that compared the effects of eating a diet high in ultra-processed foods to a diet high in whole foods found that people didn't find one diet more palatable than the other.
I also feel like I have an idea what you mean by ultra-processed, but is there a textbook definition? What is that?
That's a great question, and one that doesn't have an answer, really. There is no standardized definition. This makes it hard to compare findings across studies, since they can have slightly different parameters for how they designate a food as ultra-processed.
So sort of I know it when I eat it situation.
Yes.
Yeah, so that's tricky, though, because if everyone isn't using the same definition, it seems like that would be a pretty big limitation for any kind of studies on the effects of these ultra-processed foods.
Yeah, it certainly is. It's also another reason why it's important we take a nuanced approach when deciding how these foods fit into people's diets. For instance, a lot of ultra-processed foods, especially in the US, are fortified, meaning vitamins and minerals that aren't naturally in the product are added back in. Milk, for example, is fortified with vitamin D. One of the researchers at the conference, Lauren O'Connor at the U.S. Department of Agriculture in Washington, D.C., presented data from a recently published study that assessed the diets of more than 1,100 infants and toddlers in the U.S. She and her colleagues found that, on average, ultra-processed foods contributed to 75% of their iron intake, 48% of their zinc intake, and more than 80% of their whole grain intake.
So, which from that point of view, that actually sounds like maybe ultra-processed foods can be good?
Maybe. I don't want to definitively label them, but I do think it's important to keep in mind that there are both pros and cons to food processing, especially since these foods are cheaper and easier to prepare.
That sort of nuance, it seems sensible. My grandmother, she would often say that with food you should try to eat a little bit of everything, and she mostly used that to justify eating a slice of cake whenever she wanted. But it seems like maybe for ultra-processed foods that could be about right, that we shouldn't over-villainize them, and they can be part of a healthy diet.
Yeah, I think it means that people shouldn't rush to cut ultra-processed foods from their diet. I've been covering nutrition research for years now, and there's a lot of back and forth in the field. One minute you hear about how eggs are bad for your health, the next that they're actually good. So I personally tend to adhere to a model of everything can fit, at least in moderation. And the same is true for ultra-processed foods, because at the end of the day, food isn't solely about nutrition. It's also about culture, pleasure, and getting together with friends and family over a nice meal or to share a snack. I think it's also important to keep in mind that not all ultra-processed foods are the same. So, for example, we often think about packaged cookies or ice cream, but it also includes things like breakfast cereals, which are a great source of dietary fiber and nutrients.
Next up, this week we've had news about a breakthrough in fusion research. So we know that fusion reactors promise more energy output than current fission reactors, and virtually no toxic radioactive waste. But it's been a long road to achieving that, and this would be only the second time researchers attempting to make a fusion reactor have gotten more energy out than they put in. Technology reporter Matt Sparks is here. What's happened, Matt?
So in essence, it's just what you said. A research team has got more energy out of a fusion reaction than they put in. But really what's happened is just a slight improvement on an experiment that happened last year. So if we had to characterize this, it's a big step forward, but also if we zoom out, it's just a tiny bit of incremental progress.
How so?
If we rewind to 2021, the Lawrence Livermore National Laboratory managed to fire up a type of fusion reactor based on an idea known as inertial confinement. So what they're doing is essentially firing hugely powerful lasers at tiny capsules of fuel. And that 2021 result essentially proved that this idea worked, which is a very, very big deal. Then last year, they managed to get more power out of that reactor than they put in, which is obviously a really important milestone, and again, a very big deal. What's happened this week is that they've managed to squeeze even more power out of that same reactor.
So if we can get more power out than we put in, that sounds like fusion power could be practical right now, but I'm very skeptical about this. So, am I right? We're not quite ready to build the first commercial reactor. Is that right?
Yeah, I think that's true. So there's some really big caveats to this work, which means that we're still years and likely decades away from that. First of all, they're comparing the power output of the reactor to the power output of the lasers that kickstart the reaction. So we're talking about extracting 3.5 megajoules from a laser input of 2.1 megajoules. But the lasers draw, just for a tiny, just for a few billionths of a second, they draw 500 trillion watts, which is, yeah, that's more than the output of the whole US national grid. So this
Incredible.
is a really, it's baffling. It's a really inefficient setup, basically. It's very much a prototype or a science experiment, and it's not a commercial reactor. You're not going to make money by building nuclear reactors that use thousands of times more energy than they generate.
So what's going to happen next? Is it now all about improving the reactor or something else?
So I was told back in 2022 when they first broke even that there's lots of upgrades that can be done to increase the efficiency of that reactor, because parts of the Lawrence Livermore reactor, they're decades old. On the other hand, this isn't the main concern at the moment because it's still an experimental reactor. But these sorts of changes, they'll certainly improve that ratio of input to output, and they could be done at any time. But the really key issue is that at the moment, the reactor can only fire once for a few billionths of a second, and then it has to spend hours cooling down. It can't be run continuously, and a commercial reactor would have to run nearly continuously with sort of multiple ignitions a second. So that's a solution that needs finding. But there's lots of research groups and startups working on all sorts of weird and wonderful fusion reactor designs, and there's big tokamak projects, which are the more sort of traditional fusion reactor with vast budgets. So all that buzz going on and these positive results from Lawrence Livermore, you could easily argue that the future looks more optimistic now than it has ever before.
Okay, so I apologize in advance for this, but I'm going to have to ask you the traditional questions about nuclear fusion. The first one is, how far away is it? And the second is, will it help us in any way tackle the climate crisis?
Yeah, there's that old joke that fusion is 20 years away, and it always will be.
Yeah.
I always apologize to scientists before I ask how long fusion will take to solve, because it feels like a really unfair question. But from everything I'm told, it seems like the consensus is that it's at least years away, likely decades away. Some people have told me that if we were to do some sort of grand Manhattan Project style effort, we could definitely bring that closer. But it's still a huge problem that needs solving. As for the climate change thing, one thing's clear: we can't rely on this as a solution. There's still a chance it will never ever work. and that would leave us high and dry if we put all our eggs in that basket. And then even if it does work, it's going to come too late. So clean, abundant energy will have to come from renewable sources for at least the short term, probably the medium term.
Time for an update on all the other great things in our New Scientist podcast feed. Earlier this week, we published an interview with academic and TV presenter Alice Roberts about her new children's book, Wolf Road, and how she is using fiction as a way to share our growing understanding of early humans.
Plus, Dead Planet Society, my Burn Down the Solar System podcast with space reporter Leah Crane, is coming out with another thing to never try at home. What if we set off gravitational waves right next to Earth?
We'll have this stretching and squeezing of space and space-time, which will stretch and squeeze the planet, and the planet being stiff will resist that. But if you keep increasing the size of the wave, at some point the planet's no longer going to be resistant, so you're going to start breaking it apart.
That's coming on Tuesday.
Now, how do you map what we don't know about the human genome? Back in 2000, US President Bill Clinton announced that the first draft of the human genome was complete. And one of the surprises revealed by the Human Genome Project was that we have only around 20,000 different genes, effectively 20,000 different recipes for making proteins. And nearly a quarter of a century on, you might think that we know what all of those 20,000 proteins do. But it turns out that is far from the case. Reporter Michael LePage is here to tell us about a project to try to map these unknowns. Michael, welcome to the show.
Hi there.
I'd normally now say, tell us what you know about this one, but it seems that really I should be saying, Michael, tell us what you don't know.
Yeah, this is one about ignorance rather than our knowledge. So a team here in the UK decided to try and work out what we don't know yet about these 20,000 proteins. And the results are pretty shocking, actually. So they created this database, and based on that, we've got absolutely no idea what around 10% of these proteins do. And for around a third of them, we've got very little idea.
That is quite shocking. So how did the team go about assessing what we do and don't know about these proteins?
Obviously, it's quite a tricky one. So the team, first of all, started by grouping together all the human proteins that are very similar, because similar proteins are likely doing similar things. So that left them with around 7,500 groups of proteins. And then next, what they did is a little more surprising. So they added to each group closely related proteins that are found in well-studied animals such as mice or fruit flies. Again, because if these proteins are similar, they're likely doing the same thing.
So you're saying the fruit fly version of a protein would be doing the same thing as the human protein?
Yeah, so remember that we actually share a common ancestor with fruit flies if you go back far enough. And also that a lot of the fundamental processes that happen inside us, like turning food into energy, say, these haven't changed much, if at all, in the last 600 million years since we split from that ancestor. So a lot of the proteins haven't changed either, because they're still doing much the same thing in fruit flies as they do in us. So anyway, what the team did is they gave each of these groups of protein a score based on how many entries there are about its members in the main database on the functions of genes. What this means is that because they'd grouped together the animal and human proteins, a human protein could still score highly, even if it's never been studied directly. So if we know what the equivalent proteins in other animals do, a human protein can still get a high score. And yet, despite this, around 800 of those 7,500 proteins still scored 0. That's around 10%, as I said.
I'm wondering, not to be flip, but does it really matter? Could it be that these proteins just haven't been studied because they're not doing anything important?
Yes, it could be. So that's exactly the question the team set out to answer. So the way they did this is they selected 260 of the least known protein where there's an equivalent protein in fruit flies, because obviously it's easier to study things in fruit flies than humans. And then what they did is they lowered the level of these proteins in fruit flies to see what happens. And in 60 cases, the flies just died. So that means these proteins are doing something, really essential. And yet we don't have a clue what it is. We know nothing about them.
That's absolutely remarkable. So these are absolutely essential proteins. You drop dead, they're not working, and yet we've got no idea what they do.
Yeah, it's astonishing, isn't it?
Wow.
Yeah, so why is it? Why do we know so little about them?
So what the team leader, Sean Munro, told me is that funding agencies don't want to give scientists money to study things we know nothing about in case they don't find anything interesting. And of course, individual scientists themselves are also a bit reluctant to sort of try doing that, because it's risky for your career to spend years studying something and then you're left with nothing at the end. But what this shows is there might be some really important stuff still out there waiting to be discovered. So Munro, for instance, points out that the CRISPR proteins that we're now using to edit genes and do all sorts of amazing things, those weren't discovered until 2012. So there could be loads of really important stuff out there. So Munro's hoping that his study is going to encourage a lot more work to be done on what his team has dubbed the unknome.
The unknome. That's such a good name.
Yeah, I love that. Next up, the moon may be a tiny crescent in the sky right now, but it's still the biggest thing in space for us this week. Russia has launched their first mission to the moon in 50 years, and space reporter Leah Crane is here. Leah, does it feel a little retro to talk about Russia and the moon?
It does. It's not been a topic of conversation for quite some time. The last moon mission that Russia did was actually a Soviet moon mission in 1976. So we're sort of back in time a little bit. That mission was Luna 24, and almost 50 years later, this new mission is Luna 25.
So tell us a little bit about Luna 25. What is this mission going to do?
So it is a moon lander. It's actually really similar to Luna 24. It's going up to the moon. The idea is that it's going to land near the South Pole, which we particularly care about because the South Pole probably has some water reservoirs that people might be able to use in the future. So it's going to land there, check some stuff out, and its mission is supposed to last about a year.
As you mentioned, this is the first time Russia has sent a craft to the moon since Luna 24 over 50 years ago, around 50 years ago. Why now? Why is it going back? Why is it revitalizing the lunar program?
So Russia's space program has been sort of having a lot of high-profile failures since the 70s. It's not been going super well. There's a bunch of rocket explosions. They had a space shuttle that only ended up launching once. They had famously the Phobos Grunt Mars mission that never made it past Earth orbit. So they've been trying to do stuff. It's not been going super well, in addition to funding problems and sort of political chaos. That's part of why this mission is such a big deal, because they are trying to have an effective space program. But right now, there's a lot of brain drain, there's a lot of intellectuals leaving the country and people being killed, and obviously a loss of pretty much all of their international partnerships due to the war in Ukraine.
Is there anything we can hope from the mission from a scientific perspective?
Yeah, it's got some instruments to study moon dust mostly, but primarily it is just a proof of concept that they can still send something to land on the moon.
Okay, so they're not the only ones heading for the moon this month. Earlier this week, there was also India's Chandrayaan-3 spacecraft, which entered lunar orbit. And they're also intending to land on the South Pole. Have we got ourselves an old-fashioned space race?
A little bit, yeah. As much as I'm sort of leery of the space race framing in general, in this particular one, India and Russia were supposed to collaborate on a moon lander and then didn't. So this one in particular is kind of a race. People in India are watching the Russian launch very, very closely, especially since they're both going to the South Pole, and we're not really sure which one is going to get there first. Not that in the big picture it actually matters all that much, but politically it's quite important.
This also sounds like it could be a big deal for India if they manage to land successfully. Just a few countries have so far managed controlled landings. I mean, would that be a major milestone for India?
Absolutely. India's a relatively new player in the spaceflight scene. And if they're able to make this soft landing on the moon, it would be a huge deal.
Japan's also been planning to launch a craft to the moon this year. And the U.S. is working to send up its Artemis 3 mission in 2025, which, would bring humans back to the moon as well. I mean, it's starting to sound like there's a little bit of a risk of the moon feeling crowded.
Yeah, I think we do think of the moon as being a bit smaller than it actually is.
Yeah, fair enough.
A bunch of robots and maybe 4 people is not going to crowd out an entire, albeit small, world up there. But it's definitely a popular destination this year.
Time for a few other stories we really liked this week. First up, Tim, I have good news on the quest to head off health conditions linked to the Epstein-Barr virus.
Can you remind me, which one is that again?
It's the one that causes mononucleosis.
Oh, yeah. Yeah.
And it also is increasingly being connected to multiple sclerosis and even some cancers, which is, pretty troubling when you consider that more than 95% of the adult population is already infected with it. But researchers have been working on vaccines for this virus, and a team in Australia successfully got mice to make antibodies and T cells that target the virus.
Yeah, that's a pretty big deal. Sounds like some good news. I mean, even if it is just in mice at this point. Does this result in actually protecting the mice from multiple sclerosis or cancer?
Well, that's the catch, of course, and the next step. The team did manage to show that the vaccine had thwarted tumors, but multiple sclerosis is a much more complicated condition, and we still don't entirely understand how the immune system drives it. But the team behind this vaccine is hoping to test that out in future trials and also get this vaccine into human trials in the next couple years.
Very exciting. All right, well, next I have a story for you that's not exactly good news, but it certainly made me laugh. It's about captchas, those little "Are you a robot" tests that you see on many websites where you've sort of got to pick something to prove whether you're a human or not.
Yeah, I cannot stand those. They always send me into sort of a definitional crisis. Like it asks you to identify all the pictures that have mountains in them. And then I'm like, well, is this a mountain or a large hill? What counts?
Yeah, they drive me mad as well. But do you know who they don't drive mad? Robots. Because when I read this, I was really like, what have we come to? Because robots can not only pass those tests, they can do it a lot faster than you or I can.
Oh, great. Lovely world we've built.
This is all off the back of a study from researchers at the University of California, and they took a look at the world's 200 most popular websites, and they asked a bunch of people to take their captcha tests and then asked bots, which various researchers had coded, to look at the same sites. And humans took between 9 and 15 seconds to solve the puzzles, with an accuracy of 50 to 85%, which certainly matches with my ability on them. But meanwhile, the bots could do the same thing in under a second with an accuracy rate of 99.8%.
That's wild. Okay, well, I have one more for us, Tim. You know how I used to be known around here as the poop correspondent?
And when you say used to, what is that referring to? I think everyone's still calling you the poop correspondent. I mean, I feel a bit weird asking this, but have you got a poop scoop for us, Chelsea?
Well, I absolutely do. This is a story about a 200 million year old turd. It's fossilized feces, which are known as coprolites. And this comes from our wildlife reporter, Corinne Wetzel. The cool thing here is not the poop itself, but what was inside of it. So there were parasites. And this discovery is one of the very few times we've been able to find evidence of the parasites that infected Mesozoic animals.
It's not often you hear someone say, and the cool thing was that there were parasites. So I guess beyond the ickiness of this and the coolness from your perspective, is there some scientific value to this research?
Yeah, absolutely. So parasites might feel like a little gross or a little bothersome to us, but they affect the ecosystems that they inhabit. So understanding them can help us, get clues to the ecology and health of ancient animals. But they're really hard to actually find in the fossil record, which makes sense because they're mostly in soft tissue, which tends to not be preserved. So it turns out that poop is the perfect place to look because that's often the vector of a parasite spreading. They lay their eggs and then the animal excretes them and another animal stumbles across them. So in this case, the researchers made very thin slices of this fossilized poop, which they think belonged to a semi-aquatic crocodile-like animal. And then they examined each slice under a microscope and, lo and behold, they found tiny eggs. They were no wider than a hair.
Yeah, it sounds like we've got ourselves a bit of a very weird treasure hunt. What sort of parasites did they find?
So they identified eggs from 6 species of parasites, including nematodes, which are a kind of tiny worm. And one of the species may have been from a family of roundworms known for being intestinal parasites. So this crocodile-like animal might have got them from eating infected fish or amphibians. But while the researchers know the parasites were there, they can't tell if the crocodile creature actually got sick.
Another day, perhaps. One quick thing before we go, an update on the LK99 situation. And that's the material that its creators claim is a room temperature superconductor. But there is now mounting evidence that those claims don't actually stack up, as many replication efforts have completely failed. However, there still might be something interesting and unexpected about LK99's magnetic properties, which could explain some of the strange results it's produced so far. Our physics reporter, Carmela Padovich-Callahan, has been on top of all of the developments, and you can read her latest assessment at newscientist.com.
And I want to give a quick plug for you to get outside this weekend. The annual Perseid meteor shower is set to be the best in years, and it hits its peak in the wee hours of Saturday and Sunday. The best part, that pesky moon, will be a mere crescent, so you should have fantastic dark skies for viewing.
That's it for this week. Thanks so much for listening, and as always, our show notes have links to all the stories you heard about today.
You can subscribe to our show on whatever app you're listening on, and if you want to give us a bit of extra support, please give us a rating or review on Apple Podcasts and Spotify. Our algorithmic overlords will be pleased. Thank you, and bye for now.
Bye!
This podcast is produced by OG Podcasts. Find out more at ogpodcasts.co.uk.